Починаємо, так? Окей. Dear members of the council, let us begin our work. The Specialized Academic Council DF 26 002312 at the National Technical University of Ukraine, Ігоря Сікорський, Київ-Політехнічний Institute, was approved by the order of the University Rector number HCBC 826 dated February 11, 2026, consisting of 5 members. Chair of the Council, Анатолій Бовсуновський, Doctor of Technical Sciences, Professor at the Department of Thermal and Alternative Energy, Ігор Сікорський, Київ-Політехнічний Institute. Reviewers, Віталій Пешка, Candidate of Technical Sciences, Associate Professor, Head of the Department of Thermal and Alternative Energy, Ігор Сікорський, Київ-Політехнічний Institute. Катерина Романова, Candidate of Technical Sciences, Associate Professor at the Department of Thermal and Alternative Energy, Ігор Сікорський, Київ-Політехнічний Institute. Official Opponents, Петро Капустенко, Candidate of Technical Sciences, Associate Professor, Professor at the Department of Integrated Technologies, Processes, and Apparatuses, National Technical University, Kharkiv Polytechnic Institute. Halina Kobalava, Candidate of Technical Sciences, Associate Professor, Head of the Department of Heat Engineering, Kherson Educational and Scientific Institute of the Admiral Makarov National University of Shipbuilding. All members of the Council are present. The defense will be held online. Let's begin our work. We have a single item on our agenda, the defense of the dissertation by Lyu Yana for the degree of Doctor of Philosophy in the field of knowledge 14, electrical engineering, specialty 144, thermal power engineering. The topic of the dissertation is increasing the efficiency of contact humidifiers in the operating conditions of thermal water desalination systems. The research was carried out at the Ігор Сікорський Київ-Політехнічний Institute at the Department of Thermal and Alternative Energy within the educational program Thermal Power Engineering. Academic Supervisor Володимир Середа, Candidate of Technical Sciences, Associate Professor of the Department of Thermal and Alternative Energy, Ігор Сікорський, Київ-Політехнічний Institute. The candidate's attestation file contains all necessary documents required by the defense regulations. Having personally looked through them, I note that all documents are properly prepared and meet all established requirements. The candidate, Lyu Yana, born in 1995, graduated with a master's degree from Ігор Сікорський Київ-Політехнічний Institute in 2020. From 2020 to 2023, he studied in the postgraduate program, PhD, at Ігор Сікорський Київ-Політехнічний Institute. In 2023, after completing the third year of study, the PhD candidate took an academic leave of absence for family reasons. On October 27, 2025, the candidate was reinstated into the fourth year of the program. The conclusion of the department where the dissertation was carried out states the relevance of the scientific research, connection of the work with scientific programs, plans, and topics, scientific novelty of the obtained results, theoretical and practical significance of the results, and their implementation, approbation of the dissertation results. In general, 6 scientific publications have been published on the topic of the dissertation, including 2 papers in specialized scientific journals of Ukraine's in specialty 144, thermal power engineering, 1 paper in a scientific periodical indexed in the Scopus and Web of Science core collection databases, Q2 quartile, 3 abstracts of presentations of scientific conferences. All publications fully reflected the content of the dissertation and meet the requirements of the procedure for awarding the degree of Doctor of Philosophy. The dissertation was checked for textual overlaps using the UniCheck system. The expert Katerina Romanova, appointed by the director of the Educational and Scientific Institute of Nuclear and Thermal Power Engineering, conducted a scientific and technical review and prepared a certificate of originality, stating that the dissertation contains no elements of plagiarism. Do the members of the council have any questions regarding the candidate's personal file? No questions. Okay.
No questions.
Let's continue our work. The floor is given to the candidate to present the main findings of the dissertation. So you have up to 20 minutes for presentations. Please, you may begin. Please, Lyu Yana, your turn.
Okay, thank you very much. Okay, I will create. Good afternoon, everyone. My name is Lyu Yana. My supervisor is Sada Vladimir. Today, I'm going to present research to increasing the efficiency of conduct humidifiers in the operating conditions of thermal water desalination systems. According to the World Health Organization, 721 million people worldwide lack access to safe drinking water. The population of China is 1.6 billion. Almost 90% of coastal cities and remote regions face water shortage. The problem is especially right in the provinces of the Shandong, Liaoning, Neimenggu, Gansu, Shanxi. So to solve the problem, the researcher began to design the small-scale, low-grade desalination systems using the renewable energy, including the solar energy. These are the 4 mainstream types of desalination systems in China. In the first part of my dissertation, I examined the advantages and the disadvantages of these systems. One of the best solutions to solve the problem of the fresh water in remote regions of China will be the HT system. The main advantages are high flexibility, a low operation cost. And the HT thermal desalination system simulates the natural water cycle by eluting moisture from seawater and then condensing water vapor to produce the fresh water. There are the 2 main equipment for the HT system: a humidifier, an apparatus where heated water is sprayed and the air takes the vapor to the light, and dehumidifier where the heated water is sprayed and the air takes the vapor to the light from the moisture. The performance of the HT unit is determined by the amount of the water vapor absorbed by the air in the humidifier. This is why, in the first part of my dissertation, I reviewed the article on the study of the HT system and examined the advantages and the disadvantages of different humidifiers. The most common types are heat exchangers with the bubble column and the packaging material. In the bubble column, it's necessary to pump the air through the water surface. The packaging material, it's necessary to create the significant pressure to spray the water through the nozzles. Both need to face the significant pressure losses. The type of humidifier are complete design, but the same performance as the packaging material. The ultrasonic sprays and the rotating nozzles cost more electricity. In all this, the purpose of the work to reduce the consumption of electrical energy by the system. In order to achieve this goal, it proposed to use the film direct contact exchangers as a humidifier of the HT system. In a film-type direct contact exchanger, the liquid phase flow downwards as thin liquid along the inside wall of a vertical tube while the air flow consequently. In this work, it proposed to use a vertical tube as a humidifier, the internal volume of which is used to as an active zone of heat and mass transfer during the operation of moisture from the water to air. Such direct contact exchanger differ not in the design simplicity, but also provide low hydraulic pressure losses. The film direct contact exchanger research in our department were carried out by Professor Bowsunovsky, Assistant Professor Balabash, Solomaha, and Mr. Professor Salada. From a review of researcher papers, it's noted that the three problems of using film heat exchangers as a humidifier. The first is the airflow rate. The higher the airflow rate passes through an HT system, the greater its productivity. At the same time, the inlet in airflow is limited by the appearance of floating mode, which will lead to the distillate condensation and increase energy consumption. And the second is the mass flow region. From reviews conducted, it's established that the lower the mass flow region, the higher the energy efficiency of the HT system. However, for film heat exchangers, the minimum water flow rate is determined by maintaining a continuous volume film over the entire surface of the tube. The third, there is no accurate equation for floating and film breakup calculations, and there are no experimental data for rigid parameters of the HT system. So, today, there are no accurate methods for calculating film humidifiers for operating parameters of HT system. According to objects of my research, the first is experimental investigation of film humidifier. The second, obtain optimal rigid parameters of HT system with film humidifier. The third, to develop a mathematical model of film humidifier. The fourth, to compare obtained results with other common humidifier designs. The object of research, the process of air humidification in a film-type conduct heat exchangers under typical operating conditions of thermal water desalination systems. The object of the study, the influence of operating parameters of thermal water desalination systems on the energy characteristic of conduct humidifiers. The scientific novelty. New experimental data on hydraulic dynamic and heat and mass transfer during air purification in a wide range of changes in the main operating parameters of HT system were obtained. For the first time, the limiting value of superficial elasticity has been experimentally obtained. For the first time, the minimum value of mass flow rate coefficient necessary to ensure the continuous flow of the liquid film has been experimentally determined. The practical significance, reduction in electricity consumption required for water and the air calculation in the HT system without regarding its performance. So to achieve the established goal, the frozen method was used in experimental research, the mathematical modeling, and the comparison with other types of humidifiers. The experimental installation was developed and manufactured at our department. You can see the general review of the slide in this slide. The slide shows the installation diagram. The unit has an open air circuit and a closed water circuit. The main part of the installation is a humidifier with the legs 2 meter, diameter 26 millimeter, a water heater, a pump, a fan, a system for measuring. The specification and measurement areas are all given in this slide. The range of measurement parameters and the values of measurement areas are given in this table. The main indicators by which the efficiency of the humidifier were evaluated are the humidifier performance, specific energy consumption, operation rate, humidifier efficiency, and the gain output ratio. The result of the area calculation are presented in this table. It can be calculated that the maximum total area of the experimental result is plus or minus 11%. So, to solve the first problem, determine the optimal airflow rate, a series of experiments were carried out. As shown from the graph, the experimental value of the total air pressure drop in single flow almost coincide with the dash Weber correlations. into space flow as the water flow rate increases. The air pressure drop rise above the 50 kg each hour becomes almost independent of the air velocity. At the superficial air velocity less than 0.34, the liquid film flows down almost without waves and does interfere with the movement of the air. The first appearance of single drops from the wave surface is observed at 0.4. A drop rises the airflow osmotic and don't fall down under the influence of the gravity. At the water flow rate of 10 kg each hour, downside of the floating region is observed at 0.6. The most of liquid flowing into the lower edge tube is entered by the incoming and recycled back into the humidifier. As a result, the liquid layers form at the bottom and recycled back into the humidifier, lead to floating. However, according to the smooth form, the beginning of the flow should be here. From the obtained result, it can be studied that the drop 0.34, a sharp increase in air pressure drop is observed. In addition, at such superficial velocity, at water drop in air kinesis to avoid the necessary energy consumption and provide said water from entering the distillate, it is proposed to limit the maximum superficial air velocity in humidifier to 0.34. To solve the second problem, determine the optimal mass fluoridation. Next series of instruments were carried out. In all studies, J was constant and the water flow rate is varied, as shown from the graph. The temperature within light and the temperature out light increase as the mass fluoridation decreases, while the humidity remains constant. When the film breakup orders, the temperature within light continue to rise, whereas the temperature out light and the humidity drop sharply. This is because the disruption of the continuous falling film to reduce the intensity of the heat and mass transfer processes in the tube. As a result, the amount of the heat transfer to the air in the humidifier decreases. The effect of the mass fluoridation on the humidifier's efficiency indicators on this slide. With the decreasing mass fluoridation, humidifier performance increases and the specific energy consumption decreases, while the humidifier thermodynamic efficiency remains nearly unchanged. So reducing the water flow rate leads to the overall increase in the film humidifier efficiency. However, when the film breakup orders, the specific energy consumption increases, while the productivity and the thermal efficiency decrease significantly. This operating mode is inefficient for an HE system. Therefore, setting the minimum mass fluoridation at 2 is a reasonable approach. Under these conditions, continued liquid film flow is mandatory, ensuring the most efficient humidifier performance. In the next series of experiments was to determine the energy performance of film humidifier. All experiments were carried out at the constant J and the mass fluoridation, while the temperature within light was varied. The maximum temperature was limited to 60 degrees to prevent the swell formation in the system permanence. As shown from the graph, the higher the temperature within light, the higher the outside temperature. This helps heat and mass transfer processes in the humidifier and consequently increase its performance. As shown from the graph, the thermodynamic efficiency decreased with an increase in the temperature within light. This is due to the growing temperature differences in the upper part of the humidifier. As the temperature increases, the availability of heat and mass transfer process in the humidifier also rises. At the same time, the specific energy consumption of the humidifier remains nearly unchanged, and the goal has a constant value and doesn't depend on the heat transferred. And the operation rate is similar to the productivity, and it's reached its maximum value at the temperature 60 degrees. Therefore, at the water temperature of 60 degrees, the film humidifier has the highest performance, operation rate, and the lowest specific energy consumption. So, to determine the optimal geometry dimensions of the film humidifier, its mathematical modeling was developed using the energy software. It is in Muscat. The model includes the balance equation and the amount of heat transferred from the heated water to the air in the humidifier due to the heat and mass transfer. The correlation from computing heat and mass transfer coefficients were taken from the work. The experiments indicated the film humidifier operates most efficiently at such constant parameters. This will obtain a simplified empirical formula for an energy calculation of film humidifier for HT system. The model validation was carried out by comparing instrumental and concrete values of air and the water temperature at the humidifier outlet. So let's see the graph. All the temperature lines with an accuracy of plus or minus 4%. Let's move on to the modeling result. The absorption rate almost independent of the diameter, but values with heat from the heat 1 meter. We have the maximum value of the absorption rate, and the goal has a constant value and doesn't depend on geometry of the humidifier. And the specific energy consumption doesn't depend on heat of the tube, but we observe the slight influence of the diameter. As seen from the graph, the larger the value of the diameter, the more moisture will be absorbed by the air. A larger diameter allows more air to pass through, and the higher tubes improve the heat and mass transfer efficiency. However, with the larger diameter, the air volume passing through the central part of the tube may not reach the saturation due to the insufficient conduct area with the water and the limited actual time. With the same diameter, the performance of the 1 meter high tube will be greater than that 1-3 long tubes. This is due to the fact of the absorption rate of the 1 meter tube is the largest. So it's not available or to increase the heat of the tube by more than 1 meter. It's better to increase the number of tubes. So the optimum dimensions of the humidifier are shown in this slide. And the third method, when compare the humidifier performance with the other types. The graph shows that the film humidifier has the highest absorption rate, and the absorption rate value of the moisture are 2 times lower than the maximum absorption rate. The humidifier with packaging material have absorption rate around 100 kilogram each meter cubic each hour. The form shows that different types of humidifiers specific energy consumption. We know that the film humidifier is the lowest specific energy consumption with 0.024 kilowatt each kilogram. Graph shows that the film humidifier has the highest absorption rate at the pressure drop of approximately 25 per each meter. The absorption rate value of the moisture are 2 times lower. Also, the pressure drop are significantly lower. The humidifier with the packaging material has the lowest absorption rate with the pressure drop of approximately 100 per each meter. The highest pressure drop is observed in a bubble column. At the same time, the absorption rate of the bubble column is 1.5 times lower than the film humidifier. Therefore, the film humidifier provides the highest absorption rate with one of the lowest absorption drop. So, according to the comparison, we know that the goal is constant and doesn't depend on the type of humidifier. The thermodynamic efficiency, same as packaging material, lower than the bubble column. The absorption rate, the bubble column 1.5 times lower than percent research, and the packaging material 6 times lower than percent research. The specific energy consumption consume 10 times more than percent research. The main results were published in 6 scientific publications, including 3 junior articles, one of which is Scopus Q2 and Web of Science Q2 indexes, and another are published in the Professional Journal of Ukraine of the Candidate B, and 3 equivalence papers. The results of the dissertation work was used in the China Holistic Energy Group and the Liaoning Hongshen Environmental Solution Technical Company, which is conferred by the relevant act. The film humidifier in the form of a vertical tube was experimentally investigated in this study. For operation sensitive, the most notable operating conditions for the film humidifier occurs at jar 0.34, the mass fluorination 2, the temperature within light 60 degrees. These parameters provide the maximum performance with minimal energy consumption. New empirical relations are set for the mathematical model of a film humidifier. A comparison of the energy efficiency indicators of different types of the humidifier shows that using a vertical tube as a humidifier in an HCA system will reduce the desalination unit power and the specific energy consumption. Thank you for your attention.
Thank you very much for the good presentation. So we can start with questions. Vitaly Anatolyevich Peshko, do you have any question, please?
Thank you, Anatoly Petrovich, thank you. Mr. Yan, on slides 15 and 16, you showed us your experimental installation. So can you tell me, please, what maximum productivity did you manage to achieve it? I mean, how much clean water you get from this setup?
Okay, thank you for your question. And the maximum productivity of the pure water achieved on experimental setup is 700 column each hour from the one tube.
Okay. And how do you think, are there some limitations for further increase in productivity of your installation?
Thank you for the question. Thank you for the question. The main limitation when scaling the installation is the complexity of the design of the lower and the upper chamber due to the the number of tubes.
Okay, agree. It's clear. Thank you, Mr. Yan. Anatoly Petrovich, I have no more questions. Thank you.
Thank you, Vitaly Anatolyevich. Katerina Alexandrovna Romanov, do you have any questions?
Yes, thank you. I have two questions. First of all, in your dissertation, you identify the errors in all the calculated values. Please tell us, or better, show us on the slide what the maximum values of these errors were, and are they in line with generally accepted standards?
Okay. Thank you for the question.
Mm-hmm.
Thank you for the question. The three types of the errors of or measure instrument, and the error of the measure the values, and and the error of the calculated
Mm-hmm. And they all are in line, yes, with generally accepted standards.
And the maximum errors obtained during the study are up to the 11%, which is within the limit of the permissible values for heat and measurement instruments. And for the which is the maximum limits are plus or minus 20%, and some works even more up to plus or minus 25%.
Mm-hmm. Okay, thank you. And second short question, how do external air conditions impact on the efficiency of the humidifier?
Thank you for the question. The ambient air temperature has almost to affect the humidifier's productivity, whereas an increase relative humidity leads to the reduction in the value of productivity. However, at both parameter decreases, the energy efficiency of the coefficient also increases. And consequently, the amount of the heat required to raise the water temperature in the heater decreases.
Mm-hmm. Okay, thank you, Lyu Яна, Anatoly Petrovich. I don't have any questions.
Thank you, Katerina Alexandrovna. Thank you very much. Okay, Petro Alexeyevich Kapustenko, do you have any question? Please, if you have, you can ask them.
Oh, now you can hear me, yeah?
Yeah,
Uh,
yes. It's okay.
Okay. Just tell me, what are the advantages of your method compared to other methods of desalination?
Okay, thank you for the question. The film humidifier has advantages is the operation cost, low operation cost, and the design the design simplified, and we have the good one because we use the solar energy. We are the better desalination.
Oh, okay, thank you. And another question. Can you apply this also to some areas in Ukraine? What do you think? Your humidifier, your desalination.
I think we can use it in the Ukraine, and because we can help the Ukraine to use the tap water, because in Ukraine we have the problem of the using water, and we can use it to drink the better and live it better in the Ukraine.
Okay, it can be good for Crimea, I think, where is shortages of water. Thank you.
Okay, thank you very much.
Yeah.
Thank you. I have all questions.
Yeah, thank you very much, Petro Олексійович. And Галина Олександрівна Коболава, your questions, please.
Yeah, thank you. I have two questions. As I understood, the mathematical model was developed using the Cool probe library to determine the thermodynamic properties of the phase. And my question is, how does the change in water salinity during evaporation and the resultant salt concentration in the film affect the accuracy of your mathematical model?
Okay, thank you for the question. At feed water for the film humidifier, I consider the seawater with a standard salinity of 35 column each liter to determine the potential effect of the salt deposition on the heat and mass transfer processes. The internal preliminary experiments were conducted using the accuracy sodium chloride solution with a condensation of the 35 column each liter, which accurately simulates typical seawater conditions. To obtain the result demonstrates no noticeable in the heat and mass transfer at this concentration level. Consequently, all subsequent experiments were performed using tap water.
Okay, thank you. And one more question, that is limiting the temperature 60 degrees is sufficient to prevent scale formation on the acrylic humidifier walls during long-term operation? Is it okay, this temperature? Yeah.
Okay. Thank you for the question. Yes, the maximum temperature values were limited to 60 degrees. I can show you the degrees to scale the formation in the system's components. I can show you. I told that. Wait, please. Here we use this 60 degrees to prevent the skull formation. Yeah, thank you.
Okay, thank you.
No
more question.
Okay,
No
thank
more.
you very much, Галина Олександрівна. And I have several questions. First one, what are the advantages of your system compared to osmosis, and where in China can such systems be implemented?
So thank you for the question. The advantages of reverse osmosis and continuous operation, and the low water rate, the high water flow rate in the new manifold, the high water recovery rate, the low energy consumption, And the reverse osmosis has the disadvantages includes the additional treatment, high losses of the water flowing through this system. And our HA system has the advantages includes the high stability, low rating, and the maintenance cost, and simulated for the remote area. To improve the system efficiency, various types of renewable energy can be used. However, there's also the disadvantages such as significant energy consumption and the need to establish. HA technology has significant advantages for deployment in remote and the poor region of China, where the limiting factor is the high cost of the energy.
Okay, thank you very much. And one more question. What assumptions did you make when developing the mathematical model of the humidifier?
Thank you for the question. The following assumption was made during the simulation. The first is the humidifier operates under constant conditions. And the second is the heat losses from the equipment are not taken from the account. And the third one is the water is not salty.
Okay, thank you very much for your answers. Are there any further questions? No more? Okay.
No more questions.
Now I invite the candidate to respond to the comments contained in the reviews of the official opponents and reviewers. Please, Lü Yaνα, your turn.
Allow me to present my response to the comments and remarks by the official opponents and the reviewer. Regarding the comments from the reviewer, Vitaly Beshko, assistant professor, head of the Department of Thermal and Alternative Energy. The first comment, agreeing with the reviewer comment, a larger diameter allows more air to pass through, and the taller tube improves heat and transfer efficiency. However, at larger diameters, the air flows through the central core of the tube cannot reach the saturation due to an insufficient interfacial contact area with the water and limited actual time. For the first time, I limited the maximum diameter in this study to 50 mm. Investigating larger diameters requires additional experimental research. The second comment agreed that the reason regarding the ability to negative this drawback requires qualification. The selection of the parameters diameter 15 mm and the length 1 meter represent a technical economic trade-off. While increasing the humidified heat indeed improve its thermodynamic and exergic efficiency, it simultaneously causes a sharp increase in the aerodynamic resistance. Regarding the diameter, increasing it from 20 to 50 mm allows for more than threefold increase in the productivity, with only minimal decline in other performance indicators. Since the key performance indicators for HC systems are freshwater productivity and specific electrical energy consumption. In my opinion, it is more expedient to make a one-time increase in the solar collector area rather than continually scaling up the electrical power of the pump. The third command, the disrupted methods are recommended for use within the air Reynolds number range of 2,300 to 6,700 and the film Reynolds number range of 600 to 1,300. Since the temperature range in HA system typically varies between 20 to 60 degrees, the thermophysical properties of air and the water can be considered constant. Consequently, the formulas can be applied to air velocities in the tube region from 2 to 6 meters a second, and the mass flow rate per unit parameters from 0.076 to 0.441 kg each second. And the fourth command, agree with the command. However, I would like to note that the comprehensive analysis in the decision demonstrates that the pressure drop differences between the humidifier type are of a much larger magnitude. Specifically, the aerodynamic resistance of the bubble chrome is up to 1,000 times higher than that the proposed film humidifier. And for packet bed humidifiers, it's more than 4 times higher. Given such substantial differences, the relatively pressure drop induced by the inlet outlet tricks doesn't affect the overall comprehensive conclusions. The fifth command, agreeing that the economic assistance is essential for a comprehensive understanding of the implementation prospect of the HS technology. However, the scope of this dissertation is preliminary, focused on investigating the hydrodynamic and heat and mass transfer processes of direct contact humidifiers to accurately determine the production cost of 1 meter cubic of fresh water. A complete plant will be constructed and evaluated as part of my future research. Regarding the comment by the reviewer, Katarina Lamanova, assistant professor at the Department of the Thermal and Alternative Energy. The fourth comment, agreeing with the reviewer's comment, a comparative table would indeed enhance the reliability of the dissertation. The second comment, as the feed water for the film humidifier, I consider the seawater with a standard salinity of 35 gram each liter. To determine the potential effect of the cell deposition on the heat and mass transfer processes, the internal preliminary experiments were conducted using an accuracy sodium chlorate solution with a concentration of 35 gram each liter, which will greatly simulate typical seawater conditions. The obtained result demonstrates no notable change in the heat and mass transfer rates in this concentration level. Consequently, all subsequent experiments were performed using tap water. The third command, the uncertainty of the concluded values was assessed using the classical method described by Homan. In the dissertation, an example of the step-by-step uncertainty calculations is provided for only 1 parameters, while the standard that uncertainties of the other concluded parameters are summarized in a table. Agreeing with the reverse that given the experimental nature of this research, it would be higher appreciated to present a more detailed calculations of the errors. For example, as an appendix to the dissertation. The fourth command, the uncertain calculation was performed for all experimental data points. The maximum values were extracted from the dataset and presented in the dissertation. However, I didn't analyze the specific operating parameters under which these maximum uncertainties occurred. I will certainly take these valuable commands into account in my future research. The fifth command, I agree with the reviewer's command regarding the limitation of the proposed correlations. The empirical equation or devices specifically for the temperature range of 20 to 60 degrees, which corresponds to the typical operating conditions of solar driving HH systems, and where the base thermal physical properties of the field can be considered relatively stable. For higher temperature, it is recommended to use the equation presented in the work of the Balabash et al. Regarding the scale up to 2 bottles, it fully agrees that this introduces new aerodynamic interactions, and therefore additional experimental research is required. And the sixth command, this command is similar to the command 3 provided by the reviewer Vidal Peshko. Therefore, my response is the same. The formulas can be applied to aerosolitis in the tube region from 2 to 6 meters per second. The mass flow rate per unit parameters from 0.072 to 0.441 kilogram each metric second. For value outside these ranges, the mathematical model requires refinement. Regarding the commands by the official opponents, Nalina Kapalava, assistant professor, head of the Department of Heat Powering Energy. First command, to ensure identical flow rate in each tube of the bottle and meeting optimal operating conditions, Water disruption will be achieved using a position disruptor appliance with overflow pipes located above the upper tube sheet. This will guarantee a uniform thickness in every channel. The even supply of the air will be achieved by probing the lower inlet reservoir and utilizing increasing grid. We will focus on slowing this structure energy task in the next stage of research. The second command, for the film humidifier, direct connection of the fan and the pump to solar panels is empirical. In such configuration, the original speed would constantly fluctuate depending on solar irradiance, investigatable leading to the water film breakup and simply can't drop in system flexibility. To ensure continuous and stable electrical power supply throughout the day, it's necessary to organize an off-grid PV system with better storage. In this case, the developed state thermodynamic model remains accurate and entirely valid for concluding the system performance at any given point in time. The third command, yes, we also consider the use of the polypropylene as a construction material for the humidifier. To address this, the separate series of experimental studies were conducted using a polypropylene tube with identical geometry. The obtained results demonstrate that in the typical operating parameters of the HA system, the tube wall or material has no noticeable effect on the aerodynamic and the heat and mass transfer processes. Therefore, the developed mathematical model can be confident, recommended, and applied not only to acrylic, but also to polypropylene tube. The fourth command, a full green, the reverse insightful command, the construction and experimental testing of a full cycle stage flight is the applied stage of our research. In the correct study, they evaluate the thermodynamic potential of the developed humidifier. We updated the closed water loop model with the idealized assumption that 100% of the moisture observed by the air and condensates in the dehumidifier. And consequently, the concluded goal represents the theoretical maximum performance limit of the proposed humidifier design. We now acknowledge that in a physical full cycle system, the actual goal will be slightly lower due to inavailable thermal resistance and losses in the dehumidifier, an aspect that will be solely investigated in our future applied experiment. The fifth and the seventh, I will give one answer to these two commands to determine the potential effect of salt deposition on the heat and mass transfer processes. The preliminary experiments were conducted using an aqueous sodium chloride solution with a concentration of 35 column each liter, which completely simulates typical seawater conditions. The obtained result demonstrates no noticeable change in the heat and mass transfer rate at this concentration level. The sixth command, I follow green with the reverse command. The proposed simplified empirical volume are indeed evaluated strictly with the specified ranges. If this limit exceeded, the aerodynamic of the two-phase flow can change significantly. Therefore, for valve side ranges, the mathematical model and empirical coefficient requires further experimental refinement. The eighth command, thank you for your constructive command. Indeed, this is a more appreciated approach. Regarding the commands by the official opponents, Petro Kapustenko, assistant professor at the Department Integrated Technologies, Processes and Updates. The first command, agreeing with the reverse command, I will take this into the consideration in my future research and publications. The second command, disotopo, of course, superficial error city is dimensionless quantity. The third command, agreeing with the sentences on page 4, is widely phrased. I will revise it to make the meaning clear, specifically to clarify what the film humanified is being compared to correct grammatical structure. The fourth command, the number of the keywords has been adjusted to 15 for each language. The fourth command, in the dissertation, I compared only the humidifiers that are directly used in HA systems. In comparison with the other types of humidifiers is an aspect. I will take this into consideration in my future research and publications. And the sixth command and the second command agree with the revert command. I will take this into the consideration in my future research and publications. And the eighth command, the wall thickness of the experimental tube was 3 mm. Since the investigative film humidifiers operates on the principle of direct conduct heat and mass transfer between the boiling water film and the air stream, the thermal resistance of the wall doesn't participate in the interfacial energy exchange. The tube wall has low thermal conductivity and preliminary service as a structure battery and thermal insulations, minimizing heat losses to amplitude environment. Therefore, the wall thickness doesn't have a device influence on the internal aerodynamic and heat and mass transfer characteristic of the apparatus. The ninth command, I fully agree and that the term ascertain is technically more appreciated in this text. The value listed in table 2.1 under heading accuracy actually reliant in instrumental measurement assertions as specified by several manufacturers. The confidence level for this assertions value is 95%, which is standard for such energy equipment. I will strictly adhere to this correct metrological terminologies in my future research and publications. The 10th command is the topo. Thank you for catching that. The 11th command, under normal operating conditions at superficial velocity of just 0.34, the hydrostatic pressure drop is negligible compared to the interfacial or friction components. Regarding the floating region, the river is absolutely correct. In this state, liquid load up increases. The tube began to fill with water, and the hydrostatic pressure of the liquid phase rises sharply, becoming the diamondite factor. However, our mathematical model is strictly developed and limited to stable falling film, which is well below the floating point. Therefore, within the specified operating parameters of our system, this assumption remains entirely valid. In the 12th command, indeed, film formation and film surface turbulence locally intensify heat and mass transfer processes. However, on page 83, the term disruption refers to the transition of the continuum film into the relevant flow region, accompanied by the formation of the dry patches on the inner surface of the tube. Upon such a breakdown in continuity, the effective weighted area where water evaporates into the air decreases sharply. The negative effect of the loss in the overall interfacial conduct area significantly outweighs the positive effect of the local turbulence within the individual liquid relevant. This is precisely why the overall intensity of the heat and mass transfer processes and the total practicability of the apparatus decrease. I will certainly clarify this wording in my future publication and avoid any applicability. The 13th command, indeed, the use of the term optimal in this specific conduct requires clarification. At a strict mathematical optimization with a single objective, function was not performed. Rather, the term was used to denote the rational operating parameters. The practical threshold for selecting these values was to achieve the maximum productivity of the humidifiers while maintaining a stable falling film flow region. This is preventing a transition to the flooding region and avoiding excessive droplets in treatment. I will take this into account and use the more precise term rational parameters in my future publications. And 14th command, I will take this into consideration in my future research and publications. And the 15th command, this topo, I will take this into consideration in my future research and publications. And to the reviewers and the opponents, I greatly appreciate the time and effort you have devoted and reviewing my dissertation. Your comments and the session has been truly invaluable, and incorporating this has led to the substantial improvement in the manuscript. Thank you for helping evaluate the quality of this work. Thank you.
Okay, thank you very much. So, Vitaly Anatolievich, are you satisfied with the answers of the candidate?
Yeah, no comments. Answers are clear and relevant.
Oh, thank you very much. Katerina Alexandrovna, and you? What's your opinion? Where is our Katerina Alexandrovna? Okay, let's go. Petro Alexeyevich, are you satisfied with the candidate's answers?
Yeah, I'm completely satisfied. Everything all fine. He answered. Clear.
Okay, thank you very much. And Helena Alexandrovna, your opinion?
Yes, thank you. I'm absolutely satisfied. The answers were clear and understandable. Everything is okay. Thank you.
Okay.
Comments?
Katerina Alexandrovna, okay, maybe she has some. Katerina Alexandrovna.
She's reconnected.
Oh, okay. Katerina Alexandrovna is back. Okay, Katerina, are you satisfied with the answers of the candidate?
Voice.
Oh, yeah. Turn on your mic.
You're muted. I'm sorry. You're muted.
Yeah.
I'm sorry. Yes, all is fine. I'm agree with all of him questions.
Okay.
Answers.
Thank you very much. Okay. So we go further. Okay. Now we proceed to the discussion of the dissertation and the decision of our council concerning the awarding or non-awarding of the PhD degree to the candidate. Please, we start traditionally with Vitaly Anatolievich Peshko. Your word, please.
Thank you, Anatolій Pетrovich. I will give a brief review on my review. I will be short. Dear colleagues, Lü Yana's dissertation work, in my opinion, was completed at high scientific level. The study solves an extremely urgent problem, reducing the specific energy consumption of contact humidifiers in thermal desalination systems, which is great practical importance. The work is an independent and completed scientific research. During the analysis of the dissertation and published works, no violations of the principles of academic integrity were found. The applicant demonstrated a high level of acquisition of theoretical knowledge, successfully combining them with practice. Independent conduct of complex experiments, justification of new hydrodynamic patterns, and development of engineering calculation methods confirm his undoubted mastery of the relevant skills, abilities, and professional competencies. In terms of its relevance, practical value, and scientific novelty, the dissertation fully complies with the current requirements of the regulatory documents of Ukraine regarding the training of PhDs. And making a general conclusion, I believe that the applicant Lü Yanë fully deserves to be awarded the degree of Doctor of Philosophy in the specialty Thermal Power Engineering in the field of knowledge, electrical engineering. That's all. Thank you.
Okay, thank you very much, Anatoly. Віталій Анатолійович. Okay, next, Катерина Олександрівна Романова. What is your opinion on the subject?
Thank you. I hope I will be short on my review too. The topic of the dissertation research is indeed relevant and important today. The work demonstrates scientific novelty and provides a practical interpretation of the results obtained, and also demonstrates the author's personal contribution. In terms of content, the work fully complies with the standards of higher education in the relevant field. The dissertation itself is presented in a logical structure, is well organized, and it's acceptable to the reader. The results of the dissertation research have been published in scientific journal and presented at conference. And the last, as mentioned earlier, the work has checked for text similarities using the Unicheck system by me, which shows that it doesn't contain any elements of plagiarism. So in my opinion, the remarks that were previously raised and to which comprehensive answers were given don't affect the overall positive assessment of the work. To sum up the above, I believe that Lü Yanë dissertation on the topic increasing the efficiency of contact humidifiers in the operating conditions of thermal water desalination system, given the relevance, novelty of the results, and a high level of research conducted, meets the requirements of the procedure for awarding the degree of Doctor of Philosophy, and its author deserves to be awarded the degree of Doctor of Philosophy in the field of knowledge, electrical engineer specialty, thermal power engineer. I think I'll be quickly.
Okay, thank you very much. Thank you very much. I have no energy, you see, but we continue. Okay, Petro Alexeyevich Kapustyanko, your ideas, please.
Yeah, it's very important such work, I think, and for country of the candidate, and it is made and on a good scientific level, and also it's supported by the data of experiments. And the dissertation was completed at a higher scientific level and does not violate the principles of academic integrity. And it is complete scientific study. The combination of theoretical and practical results of which solves the scientific problem that is of significant importance for the field of the knowledge in electrical engineering. In terms of relevance, practical value, and scientific novelty, the dissertation fully complies with the requirements of the current legislation of Ukraine, as provided by corresponding paragraphs of the on awarding the degree of Doctor of Philosophy of Ukraine. So the applicant, young Lü, deserves to be awarded the degree of Doctor of Philosophy in the field of knowledge 14, electrical engineering, specialty 144, thermal power engineering. So it's my opinion.
Thank you very much. Thank you very much. And Katerina Alexandrovna Kobalava, your opinion.
Okay, thank you. Dear colleagues, I won't be My speech won't be long, I guess. The dissertation presented by Lü Yan on increasing the efficiency of contact humidifiers is a highly relevant and completed scientific study that addresses the critical issue of decentralized freshwater supply in regions facing acute water scarcity. For the first time, the author has experimentally established the limiting superficial velocity and the minimum mass flow rate ratio, which prevents distillate contamination and minimizes pressure losses. His research findings were presented at international conferences and reflected in 6 scientific publications. So, in my opinion, the applicant strictly adheres to the principles of academic integrity. In this way, my overall impression of the work is positive. Considering the research scope, scientific novelty, and practical significance, Lü Yan's dissertation fully meets the requirements for qualification papers at the PhD level. The candidate has proven to be a mature scientist capable of solving complex engineering problems in the field of thermal power engineering, and I strongly believe that Lü Yan deserves to be awarded the degree of Doctor of Philosophy in Specialty 144, Thermal Power Engineering. That's all what I wanted to say. Thank you.
Thank you very much. Thank you. Okay, and dear colleagues, I completely agree with you that the dissertation of Lü Yan is carried out at a sufficiently higher scientific level. The dissertation, in fact, contains results that have scientific and practical significance. The training that Lü Yan received while doing research allowed him to achieve a high scientific and professional level, which enabled him to be successful in his future work. By its relevance, practical value, and scientific novelty, the dissertation fully meets the requirements of the current legislation of Ukraine. So, in my opinion, Lü Yan deserves to be awarded the degree of Doctor of Philosophy in the field of knowledge 14, electrical engineering, in the specialty 144, thermal power engineering. So we expressed our ideas, and we can go to the final stage of our work. So now proceed to the voting. As far as we work online, we should express our decision by voice. It's better. In favor or opposed. If you don't mind, I will name the members of the council in turn, as we did before. So we'll start with Vitaly Anatolievich Peshka. Your decision.
Peshka votes in favor.
In favor. Okay. Katerina Alexandrivna Romanova.
Romanova in favor.
Thank you. Petro Alexeyevich Kapustenko.
I vote in favor. In favor.
Thank you very much. And Galina Alexandrivna Kobalava.
Yeah, Kobalava, I support the award of the degree.
Okay. Thank you very much. And me, I vote in favor. Well, so no one is opposed, no abstention. So the decision is adopted unanimously. Thus, based on the results of the open voting, 5 council members in favor, none opposed, no abstentions. The one-time specialized academic council, DF 26002-312, has made the decision to award the degree of Doctor of Philosophy to Lü Yan in the field of knowledge 14, electrical engineering, specialty 144, thermal power engineering. Let me, dear colleagues, on behalf of the Council, to congratulate Lyu Yan on the successful defense of the dissertation and the awarding of the Doctor of Philosophy degree at Ігоря Сікорський Kyiv Polytechnic Institute, and to wish him the best in the future. Congratulations. Okay, and dear colleagues, maybe Lyu Yan want to say something.
Yeah, so thank you very much. Thank you all the reviewer and organizers, and thank you my supervision, Sarada graduate, and thank you my start life, because when I was 18, I was in the Ukraine. So I missed the Ukraine, and I think the Ukraine will be the better. And have a nice day. Thank you very much. Thank you all the people.
Okay, thank you. Thank you very much. Thank you very much. So, dear colleagues, with this, the agenda of our council meeting is concluded. Thank you very much for the fruitful work. Thank you. And I wish you all the best. So we can end our translation. Yes.
Really fruitful. Яке класне слово.
Yeah. Agree.
Thank you very much.
Thank you. Okay. Okay.